robots. In today's section we are gonna learn about TensorFlow. Now in the previous video we talk about machine learning and how machine learning work. But in the today's section we are gonna implement the TensorFlow, and for that we are gonna use Jupyter Notebook. So I made a project named all-in-one code TensorFlow hello world.ipynb. Now in this project I am gonna create a hello world program in TensorFlow. But before starting, if you didn't subscribe my channel, so please subscribe my YouTube channel and hit like and hit on the bell icon so you'll never miss my any videos. So now let's begin. So let's first import the TensorFlow, and for that just write import TensorFlow as TF. You can name it anything, but I'm gonna name it TF. So let's run this program and see what we got. You can see it and there is no error. So we just imported our TensorFlow. Now let's first find out the version of TensorFlow, and that's why we keyword or you can say function. So and for that I'm gonna just print tf dot versions. So versions, and that's how you can check out the TensorFlow version. And you can see I got the output 2.0.0, and if you are watching my video after 1 or 2 years, so the output is changed, but we got the 2.0.0. It means my TensorFlow version is 2.0.0. Now you can see here we are gonna import the fashion MNIST dataset. Now in the previous artificial intelligence series we learned what is classifier, how to create labels and features, and in this video we are gonna just simply import the features and labels, and for that we are gonna just use fashion MNIST dataset. So you can see here this dataset is help us to find is this a t-shirt, dress, coat, sandal, shirt and so on. So you can see here the label is for 0 t-shirt and top, and for 1 trouser, and 2 pullover, and 3 dress and so on. So we got labels in here and features, and for that we just need to do is import the MNIST dataset, and then we are gonna train and test our data. So let's just import the MNIST dataset, and for that I'm gonna name it a variable fashion MNIST equal to, you can name it anything, and for that we are gonna use Keras. Now what is Keras? So Keras has a loads of dataset available you can use for learning your skills, and for that we are gonna use keras.datasets, and from keras.datasets we are gonna import or you can say use fashion MNIST. So this is our variable, but first we need to import Keras, and for we are gonna import some libraries. So the Kera is the part of TensorFlow, and for that we are gonna use from TensorFlow import Keras. Let's run this code. Okay, I got error in here because TensorFlow core.keras has no attribute datasets. Let's first import the Keras. Let's run this code again. You can see we didn't got error, so it means Kera is successfully installed. Now let's create a variable. You can name it anything, but I'm gonna name it fashion MNIST equal to keras.datasets.fashion MNIST. Okay, let's run this code. Okay, we didn't got error. It means this code is run successfully. Now that we got all the data, it means it has a fashion, feature and labels. Okay, but which? You can see here this is our labels class, Now if you wanted to know what is the features in our data, so let's just create a class. So in here I'm gonna create a variable and name it class names, because we need this class's name in the graph. And for that I'm gonna just create a class. Class is the list, and in the list I'm simply gonna add all the labels in the string format. You can see t-shirt, top, trouser, pullover, dress, coat, and so on so. And we are gonna use this class later. For now let's run this code. Okay, now that we got data, let's create a features and labels. In features we got all of this stuff, and from this stuff we are gonna create a train data and the test data at the same time. And for that we are gonna train the image and train the labels. So for that I'm gonna create two variables, train image and train labels. Now again I'm gonna copy this code and paste it, and I'm gonna change train to test. So I'm gonna just change train to test because we need test data. And if you don't know what is this, check out my previous video. Now equal to, simply I'm gonna use all of this data, fashion MNIST, fashion MNIST dot load data. So we got all of the data in the train image and train labels, and the test image and test label. I know some people talking about why we used all of the data in the train and the test, but hold on a second, we are gonna change the data later. But first we got all of the data. Let's run this code. Okay, now that we got data, let's explore the data. First we are gonna check the shape. Let's print train image dot shape. Okay, this is not a function. Okay, let's run this code, and whenever I click run, you can see I got 6, 40, 28 and 28. So this is the shape of train image. Now let's change this, and now let's just print train labels. And for that I'm gonna use label, and I'm gonna run the code. You can see I got a huge list in here. Let's change this and let's try images. Let's run the code again, and boom, we got huge list in here. This is the 3-dimensional array. Okay, that's enough exploring. Now let's remove this code. Now that we explore the data, let's process the data. And for that we need one library named import matplotlib. Matplotlib is a helpful library if you are a machine learning programmer. So I'm gonna just import matplotlib dot pyplot. Pyplot is helpful if you wanted to show a graph and graphical expression. Let's run this. Okay, now we got matplotlib.pyplot. So now we are gonna use the PLT, and for that first thing to do is we are gonna use plt.figure function. And if you learn more about pyplot, so please comment now. I'm gonna create another playlist for matplotlib and a graphs library. Okay, now we just need to do is plt.figure. We are gonna use the figure function now, and now we are gonna use the plt.imshow function. So the imshow function take up one argument what you wanted to show, and I wanted to see train images, and that's why I'm I'm gonna use train image is 0. Now why 0? Because we are gonna just see the first data, and for that we just used train image of 0, and then we are gonna use plt.colorbar function, and then we are gonna use plt.grid, and grid is help us to make a grid. Now I'm gonna false the grid. Okay, and the last one is we are gonna display the show method. So the function is plt.show. Okay, let's run this code, and you can see we got a picture in here. So this is our graph. Now I know some people don't know what is it. Let's change the value in here. Let's try one image, first image. Okay, this is the t-shirt. So the 0 is I think boot. So this is the shoe. Let's try second one. Okay, this is I don't know what is it. Let's try again 8. Let's run. Okay, this is the sandal or something, I don't know. Let's try again 5th. That's how you can check out the. Now I know this graph is seen like a pixel, but that's how machine can learn. Okay, but for now we are gonna use a 0. So this is the boots. Now you can scan and scale the all value to a range 0 to 1 before feeding them to a neural network model. Okay, and for that divide the value by 255, and it's important to that the training data set and the testing data set be pre-processed in the same way. Now let's create our train image and test image divided by 255, and for that I'm gonna just paste my upper code in here, and I'm gonna divide it by 255. So you can see here train image equal to train image divided 255, test image equal to test image divided 255, and I used dot value for showing this is the float value. Now that we got data, to verify that the data is in the correct format, and now you are ready to learn and build the train neural network. So now let's display the first 25 image from the training sets and display the class name below. And now we are gonna use this class name. Where's our class name? Yes. And now we are gonna use this class name in here. But for now, let's run this code. We are gonna use this same method. So I'm gonna just copy this code and paste in here. For your better view, I'm gonna just comment it out. You can see I just comment it. Okay, now we are gonna use the for loop to display first 25 image, and for that first I'm gonna use plt.figure, and in the parameter I'm gonna just add a one parameter, fig size equal to 10 is better for now. Okay, now we are gonna take a for loop in here for I in range to the 25, and in the for loop we are gonna use some function in here. Okay, so the first function is plt.subplot, and in here you have to add 3 parameters. So first is 5 and I plus 1, so it can increment the value. Now if you wanted to know what is subplot function, comment me to create another series for this. Okay, but for now we are gonna use another function plt.xtics, and in the parameter we are gonna add a null list, and same as plt.xticks we are gonna use plt.yticks, and again we are gonna use plt.grid, false. And now we are gonna show the image with plt.imshow function, or you can say method, and we are gonna print one by one value. So for that I'm gonna just use train images of I one by one, and we are gonna add another parameter in here, cmap equal to plt.cm.binary. I am not talking about PLT more because this isn't a part of machine learning. This is just help us to see what we are doing. Now the second last one function is plt.xlabel, and in the parameter we are gonna simply just add class names because we need to show class names, and class names of trained labels of I. Okay, now that's done our job in here. Let's just simply display the all of the image, and for that we are gonna just simply use plt.show function. Let's run this, and you can see we got 25 images in here. The first one is ankle boot, the second one is t-shirt, third one is t-shirt 2. This is not seen like a t-shirt, and dress and t-shirt and pullover, sneakers, and so on. And that's how you can see which features and labels available in here. So this all is our labels, and that's how you can see what data we have available in our data sets. Now that we got all of the data, oh, this is the sandal. Okay, now that we got all of the data, we are gonna build a model in here. But how we are gonna do this? And for that we are gonna use keras.sequentialize method in here. Now build the neural network requires configuring the layers of the model, then compiling the model. Now let's create a layer. So basically building blocks of neural network is the layer. Layer extracts representation from the data fed into them. Hopefully these representations are meaningful at the problem of hand. Most of the deep learning consists of changing together into the layer. Now such as keras.layers.dense have parameters that are learned during the data training. So we are gonna create a model in here. For that you can name it anything. I'm gonna name it model equal to, we are gonna use keras dot, we have function sequentialize, and in this function we are gonna pass the list of layers. So this is the list of layers. So the first one is keras.layers.flatten, input shape equal to 28. So the second one is keras.layers.dense, 128, activation equal to ReLU. And the third one is keras.layers.dense, 10, activation equal to softmax. Okay, now that we got a model, first let's run this model. Okay, I got error, invalid syntax. Okay, I forgot to add this in here. Okay, let's run this code again. Okay, now that we got model, so the first layer in here is a network. So the flatten is transform the formats of the images from a 2-dimension array of 28 by 28 pixel to a one-dimensional array of 28 into 28 equal to 784 pixels. Okay, that's what the first layer is doing. For that I'm gonna create a comment line in here. So that's why I didn't forget what this does. So you can see the first layer in this network, tf.keras.flatten, transform the format of the image from a two-dimensional array of 20 by 20 pixel to one-dimensional array of 20 into 28 equal to 784 pixels. Think of this layer as unstacking row of pixels in the image and lining them up. This layer has no parameter to learn, it only reforms the data. Okay, reformats the data. Okay, now what second layer does? After the pixels are flattened, the network consists of a sequence of two tk.keras.layers.dense layers. These are densely connected or fully connected neural networks. The first dense layer has 128 nodes or neurons. The second and last layer is a 10-node softmax layers that return an array of 10 probability scores that sum up to 1. Each node contains a score that indicates the probability that the current image belongs to one of the 10 classes. Okay, so this contains a neural network. So model is like brain of us, and in this model we got neurons, we got neural networks. Okay, now that we got model, which is the very important part of machine learning, we are gonna compile the model. But that is it for today's guys. The next video we are gonna compile the models, and then we are gonna train the models, and then we are gonna feed the models, and we are gonna predict the data and see what machine can predict. Okay, so that is it for today's guys. If you like this video, if you learn something, so please like this video and comment me for the pilot graphical library series, and subscribe to my YouTube channel for latest update and motivate us, and hit on the bell icon so you can never miss our new video. Thank you.